Today, people, we are starting the beginnings of geometry. Who here knows what geometry is? Shapes, sides. It's a lot of stuff that construction workers use, right? Which means if you want to get into the construction field, I suggest you learn a little geometry. Chris, you're going to enter the construction field? Bart, you're going to enter the construction field? Navi, you're going to enter the construction field?
In real life?
Yeah.
No. I think I'm going to do it.
What about you, Randy or David? So, are you going to enter the construction field? What was your answer? So, as I thought, everyone is going to enter the construction field, which means everyone should master this. So let's do this. The beginnings of geometry. Before we get into shapes and learning how the area and perimeter and sides and this and that and volume, this and that, we got to do a very special thing. It's considered the tail end of algebra. It's sort of still involving equations and everything that we've mastered, but it's more the geometry side. First things first. Do we know what shape this is? You know what? Let's make it better. How about that? Ooh, nice. How was that?
Cool.
All right. What shape is this called? No. What shape is this?
This word, I know you.
Yeah. I think it's time that you finally talk. I think you got this one at least. What shape is this? I suggest you start taking notes. What shape is this, you guys? Come on. Triangle. Yes. Very specific triangle. This one is called a right triangle. Right? Do we know why it's called a right triangle? Thank you. Because of that little box on the side, do you know what that means? 90-degree angle. It's a perfect not a square, but yeah, it's the corner edge of a square, right? It's a 90-degree angle. It's a line with another line, creating a perfect straight edge corner piece, right? That's a 90-degree angle. This right triangle, yes, you are correct, is technically half of a square if you really look at it, right? If we were to get another one, oh, this is going to be the moment of truth to see whether technology is this cool. Are you guys ready? If I were to copy this image, let's see whether I can do this. If I were to copy this image and twist it, would it form a square? Too small. It's because I made it, oh my gosh. Look at that, how beautiful that is. That's technology for you. I can't believe I did that. So, a right triangle, it's pretty much half a square, right? Or half a rectangular prism. That's a right triangle, right? It's important to know what a right triangle is because of today's lesson. Today's lesson is the Pythagorean Theorem. Who here knows what that is?
I learned it, but
I hate it part. I have to prove it.
So, the right triangle is a cool thing, right? Because you could find the area and perimeter and stuff of a right triangle, a regular triangle, a square, a parallelogram, all these shapes, right? But when you're given a question, a very specific question, and it asks for the missing side, for instance, if they were to give you 5 here, 6 there, actually that looks off, 6 there, 5 here, and they were to say, what is that distance of the missing side of your right triangle, you use something called the Pythagorean Theorem. All right? Only for the right triangle. We're doing that today. So, the Pythagorean Theorem. Who knows what that is? The very famous a squared plus b squared equals c squared. These are one of the formulas that those of you that are taking your GED do have it on your formula sheet. But it's one of those that just rolls off the tongue that you should memorize it. It should be one of those things in which when you're given a word problem or just a straight up right triangle and you're told to find the missing side of that right triangle, your mind should go straight to a squared plus b squared plus c squared equals c squared. All right? The Pythagorean theorem is used to find the missing dimension of a right triangle. That's all it's used for. So if you're given a question that says, what is the area of the given figure, and you're given a picture of a triangle or something, a squared plus b squared equals c squared should be far from your mind. That's to find area, that's to find perimeter. They ask you anything else like that, you're not using the Pythagorean theorem. You use the Pythagorean theorem to find the missing side. One of those missing sides. So, let's use this example. So, first lesson, the two sides, this side and that side, they are connected to the 90-degree angle box, right? Do you see that? Which means those sides are your A and B. It doesn't matter which one, whether this is A and this is B, or that's A and this B. I like thinking the bottom one is B because of base, right? It just helps me, or B for bottom, perfect, right? It just helps me, but it really doesn't matter. But that's your A and your B. The long part, my friends, the X side, that is your C. The C has a specific name. Do we know the name of the long part? Hypotenuse. Has anyone ever seen Key and Peele? Only 2 people's laughing at that. Key and Peele is a show in which I already forgot the skit, I already forgot the joke, but there was a class and the teacher was the teacher was going over this, a squared plus b squared equals c squared, and then one kid she mentioned the hypotenuse. She was like, the C is called the hypotenuse. And some kid leans over and was like, I want to get high on potnuse, or something like that, right? I want to get high on potnuse, high on pot, right? And then, the kid steals this joke, and I don't know, he becomes he becomes president. I don't know. It's really stupid. But if that's what's needed to help you remember that the long part is your hypotenuse, go for it. C is called the hypotenuse. All right. So, we know a squared plus b squared equals c squared, right? We know this side is a and this side is b, or vice versa, doesn't matter. Guess what we do, you guys? We get those numbers and we put it into a and b, right? That's simple. Do you remember a couple weeks back when we were going over evaluating expressions? What was the rule when you substitute a variable with numbers? What's the rule when you get numbers and you substitute it in for parentheses, right? With the Pythagorean theorem, it doesn't really matter because you're just dealing with positive numbers. So you don't really have to deal too much with issues if you don't put the parentheses. But this goes to show you how dedicated I am to my rules, that guess what? I'm going to do it. Oopsies. You see that? Doesn't hurt. Gets you the habit of putting parentheses when substituting variables with numbers. Okay. A squared plus b squared equals c squared. All right. All this is now, you guys, is an equation problem. Wow. Chris decided to drop everything onto his table. Let me push pause. Okay, so now we're back. And I said, this is now an equation problem, right? Do we remember how to solve equations? Split the sides. Make sure you simplify each side first. So, is there anything to do on this side? It's a c squared. I don't know what to do there. Is there anything to do on this side?
Yes.
What could I do on this side? Yeah. Yeah, you guys. What's 6 squared? Plus, what's 5 squared? Equals c squared. All right, so is there anything else I could do on this side? Really?
Add it.
Yeah, you could add it. What's 36 plus 25? Do you see what I did there? Now there's one more thing you need to do. I'm going to start a new one. I had 61 equals c squared, right? That's what we had? The Pythagorean Theorem. Your last step is to always, always, always square root your answer. Because we technically found c squared. Do you see that? You guys see that? C squared, we found it. It does not make sense, though, that if we go back, it does not make sense to make x 61. 6 inches, 6 feet, doesn't matter, 6 whatever, 5 whatever, and then 61 whatever? That's too much of a difference. That's because we didn't find c. We found c squared, which means I want to find c. How do you find just c? You do that by square rooting your answer. What's the square root of 61? Yes, this is where you take out the calculator. Oh yeah, oh yeah. 7.8 equals C. Does it make sense that this side is 7.8? Does that look a lot better? Oh yes it does. 6, 5, and 7.8. By the way, a little hint for you. Your hypotenuse must always be bigger than either other side. These, side A and side B, should never be bigger than your C. If you ever come out with something smaller than a 6 or something smaller than a 5, you have the wrong number. You did something wrong. This long part is always going to be bigger. So, your last step with the Pythagorean theorem is always to find, or always to square root. Make sense? Pretty straightforward, right? Now, of course, comes the hard problems. Let's say, my friends, let's say that you're given this. Do you see what happened there? Do we see what happened there?
Yeah. We saw what happened there.
What's different about this problem?
We have the hypotenuse on the base.
The Pythagorean theorem is a squared plus b squared equals c squared, right? In this specific case, one of my sides are missing. But we are given the c. We are given the hypotenuse. Yeah. So guess what? If we fill it in, why not? I like parentheses. This is how we have it now. Do you see that? So now guess what? It's just like solving equations still. Except now you got to do a little extra step. But we've all mastered equations, which means we all know how to solve for A. What must I do first? You're going to start moving stuff immediately?
No look at it, it's fine.
Oh, no. Always ask yourself, what could we do on each side? Is there anything to simplify on this side over here?
No. Or we can
Yes, there is.
do
What?
3
The
squared.
3 squared.
What's 3 squared?
9.
You see? There's something to do.
And then there's the 8 squared.
What could we do on that other side?
64. 8 squared.
Right? Before you ever move stuff, simplify. So, how do I leave A by itself? What must I do now?
That will move the 9.
How?
Make a negative 9 instead of the
Yeah.
It's all coming back. You see, this is why Pythagorean theorem is still part of algebra. A squared equals, what is 64 minus 9?
55.
Is that your answer? Are you done?
No.
Huh?
No.
What do I got to do?
Do it into the square root.
Yeah, I want to look for A, not A squared, so I'm going to square root the 55. What is the square root of 55?
7.4.
Does it make sense that this side, side A, is 7.4?
Yeah.
Does it make sense?
Yep.
Is it less than your hypotenuse?
Yeah.
Then you're safe, right? The hypotenuse must always be bigger. This problem right here, these type of problems right here are the types of problems that you're going to be given on your WAMAP, your GED, my quiz. Those ones. A squared plus B squared to find C squared is too easy. So instead, they give you the C squared and they give you a missing piece of the other side, and it's your job to do this to solve for it. So, now one last thing. How do Pythagorean theorem problems look like? Because chances are that yes, they could give you a straight up problem like this. They could. And they could be like, what is x? Right? But that's not what people like to do. That's not what tests like to do. That's not what teachers don't like to do. We like to make things difficult, right? So, problems look more like this. They're more of word problems. So what they do is this. Right? And then they do this. Right? And then the word problem goes like this. This is how the word problem goes. It says, a newly founded neighborhood, I don't know, just installed 3 telephone poles located miles apart. Telephone pole X, Y, and Z. Right? And then it said something like this. The distance from X to Y is 30 miles. Right? It's a big neighborhood. The distance from Y to Z is 50 miles. Then the question says, what is the distance from telephone pole Z to X? Right? A lot of students in that situation, when they're in front of the computer, and they click on the next problem, and then this problem pops up. And they read all that, and they see this little diagram, and they're just there like, what? And then they guess, and then they go to the next problem. Not knowing that, hey, this is just the Pythagorean theorem problem, right? Because let's look at it. If you were to draw out what they gave you, the distance from X to Y was 30 miles. The distance from Y to Z was what? 50 miles, I said? Or 55? 55 miles. What is the distance from X to Z? And chances are they'll actually tell you something like this because they won't make it too hard. They'll tell you the angle of I don't know, they'll tell you somehow that this is your 90-degree angle right there. Yeah. Huh? Yeah, well, if you know that's your 90-degree angle spot, what were the sides that are given?
But if they just give you like click one like that, how can you prove that?
That's the 90-degree angle?
Yeah.
They'll tell you somehow. They'll say telephone pole X is a 90-degree angle spot or whatever, right?
Yeah.
They'll tell you somehow because they're not that mean, all right? We're not that mean. We'll provide some sort of suggestion, right? So if we know that's the 90-degree angle spot, guess what? This one and that one is my A and B, right? And this is my C, right? It might not look it. They're all really similar in distance. But guess what? Like I said, the sides that are connected to your 90-degree angle is always your A and B. So if we're given, or actually you tell me, what are we given? What's my A squared? Okay, sorry, say that again. Because we don't have it? Okay, so what's my B squared? What's my C squared? Let's solve our equation then. What can I do on this side? What does that become? $913? What's my 55 squared? Because now we're moving on to this side.
No, I said 900, not 900.
I thought I heard 913.
No.
Jeez.
900.
All right, so what's my 55 squared?
That's a big one.
Say, what was it?
It was 2025.
3,025?
That's a big one.
All right, what do I do now?
Make it to negative 970.
Everyone should be listening and looking up. A squared equals, what's 3,025 minus 900?
2075.
Seriously?
Yeah.
I got different answers.
You have the calculator, tell me.
That's 2,125.
Damn it, Non. 125?
Yeah.
Or Non? Chris, sorry. I know. I don't know why it's such... He hasn't been showing up, by the way, so you need to do something about that. Yeah. Because you get him in check. Okay. So, did I find my distance from x to z? Is my distance 2,125 miles? Yep, I have to square root this. What's the square root of 2,125?
46.0.
46?
46.1.
Does it make sense that the distance from x to z is 46.1 miles? That's how you... It's a Pythagorean theorem. It's just like we've been doing, except guess what? It's your job to spot when you have something like that. Another famous problem is the famous tree. A famous tree, right? It casts a shadow. It casts a shadow. It says that the tree is 6 feet tall. The distance from the top of the tree to the bottom is 5 feet. And they want to know, how big is your shadow? Like something like this. They want to know what your shadow is. Pythagorean theorem. They form a right triangle, which means you use the sides or you're trying to look for the missing side, which means Pythagorean theorem. The Pythagorean theorem is used to find the missing side of a right triangle. So many different ways problems could be given. But it's your job to know it's the Pythagorean theorem. Are we ready to start our practice problems? Can you use the calculator? Is that what you said?
I need the calculator.
Oh, you need a calculator. Yeah. Let's do this, you guys.